for this problem, we're asked to identify the center, vertices, co-vertices, and foci of the given ellipse. And then we're supposed to sketch the graph of the said ellipse. Now, since we're given an equation which is not in standard form, that's the first thing that we have to do. So we have to transform this into the standard form of an ellipse so that it would be easy for us to identify the center as well as the values for A and B. So to do that, we group together x squared and 6x plus 9y squared minus 90y is equal to negative 225. And then completing the square, we have x squared plus 6x plus 9 plus, in this case, I'll factor out 9. We have 9y squared minus 10y plus 25. And then to maintain the equality, we add on the right-hand side the same values that we added on the left. So plus 9 plus 225. So this 225 comes from this 25 times 9. So then simplifying this, we have x plus 3 squared plus 9 times y minus 5 squared is equal to 9. And then finally, we divide everything by 9 so that we'll have 1 on the right hand side, and then on the left we have x plus 3 squared over 9 plus y minus 5 squared. So we cancel these out. So from this standard form of the equation, we can easily identify the center. So the center here is negative 3, 5, right? Because it's x minus h squared plus y minus k squared. And then the value here of A is 3 since A squared is 9, and then B is 1, right? So from these values, we can also easily identify the vertices because we know for a fact that the vertices of an ellipse is just A units from the center. So therefore, we have vertices. If the center is negative 3, 5 right here, and we know that the major axis is the horizontal axis because the larger denominator is, or the value of A is under x squared. So 3 units from the center, negative 3, 5, that's 1, 2, 3. This one, which is 0, 5. And on the other side, 1, 2, 3, that is negative 6, 5. All right, for the co-vertices, it's B units above and below the center. So if this is the center, B units, so 1 unit below that, that's this one, and 1 unit above that. So we'll have, this is negative 3, 4, and then above we have negative 3, 6. Okay, and then finally, for us to solve for the location of the foci, we have to compute for the value of C first. Using the formula, A squared is equal to B squared plus C squared, right? So we have the value of A, that's 3 squared, is equal to 1 squared plus C squared, which will yield 9 minus 1 equals C squared. C squared is 8, therefore C is 2 square root of 2. So the foci is C units from the center. So therefore, we'll have, so from negative 3, 3 units to the left and to the right of that. So that's negative 3 plus 2 square root of 2, 5, and negative 3 minus 2 square root of 2, 5, which is equivalent to Negative 3 plus 2 square root of 2 is negative 0.17. So this is approximately negative 0.175. And this is negative 3 minus 2 square root of 2 is negative 5.82. 5. All right, so we have all the values that we're supposed to look for. So now sketching the graph, again, we have the center here, the vertices here, the co-vertices here, and the foci somewhere, negative 0.17 somewhere here, 5.82 somewhere here, and then we connect the co-vertices and vertices to have our ellipse. And then if we were to connect the vertices, we'll have the major axis right here and the minor axis here. There you go.